Hey guys, so it's 2 a.m. I need to finish. I need to finish the. How can I say it? Yeah, I need to finish my IPC 144. I'm just preparing for the quiz. Okay, so I'm just gonna record this video just for future references. Okay, so right now we were talking about logic. Okay, so I'm just gonna create a notepad. Okay, so so with logic there are three things that we need to make sure that we know it. Okay, we have sequential structures, we have selection structures, and finally we have iteration structures. So what's the difference between sequential structures, selection structures, or iteration structures? So first we have sequential structures. Sequential structures is just a set of instructions executed in order. Okay, it's executed in order. So it's like A, then do B, then do C. Okay, that's a sequential structure. So sequential structure can be divided into simple statements, and it can be a code block. So there's a huge difference between those things. So simple statements, it's just okay, do this. Okay, but when we're talking about a code block, it's like do this, then do this, then do this. So it's like more instructions. Okay, that's why we call it a code block, which is large. Whereas a simple statement is just one instruction. Okay, but before continuing with the selection structure, we're going to talk about pseudocode. Pseudocode versus flowchart. So what's pseudocode and what's flowchart? So pseudocode is just a set of instructions itemized, okay, in order to give a programming solution, whereas a flowchart is the use of conventional symbols that are connected by arrows and illustrates how a program works and gives a programming solution. So those are different ways. Okay, so now we're going back to the selection structure. So what's a selection structure? Selection structure, as I said before, or not. Okay, selection structure is just a set of different paths through a set of instructions. So it's like you go this or you go this and then do this. Okay, so you have like options. Okay, and there are three types of selection structures. We have optional selection, optional path, then we have alternative path, then we have optional path, we have alternative path, and then we have conditional path. Conditional expression. So what's an optional path? So an optional path is just basically if statement with a condition, and if the condition is true, then to this sequence. Okay, that's basically the optional path. Okay, but then we have alternative path. So it's like with alternative path you have binary selection and you have multiple selection. Okay, so what's the difference between binary selection and multiple selection? With binary selection, it comes from two. Okay, so it's like if this condition is true, then do this condition, do this sequence. Okay, if the condition is not true, then go with an else and you go with a sequence. Okay, and that's basically a binary selection. Then we have multiple selection. Okay, so with multiple selection, anyways, so with a multiple selection, you have multiple choices. So you have a condition. If the condition is true, then do this. If not, if the first condition is not true, then you go to the second if. So if this is true, then you do this. Okay, but if not, then do this. Okay, like you have multiple choices, right? So it's like a multiple selection basically. And finally, and you can also have like several else if as much as you want, but it's kind of tedious. Okay, and then before going to we're going to conditional expression. So what's conditional expression? So a conditional expression is like how can I say it? You have this condition. So if the condition is true, okay, you do this. Okay, now it's like I can remember like this. X equals to, if the condition is true, then x equals to a. If not, then x equals to b. So that's how I remember. Okay, that's like a conditional expression. Okay, so if the condition is true, x becomes a. If the condition is false, x becomes b. Okay, and that's like a conditional expression. Okay. Oh, okay. Before going to iteration structures, I'm gonna mention about a case by case. So what does case by case do? So case by case is like using a switch statement. So with a switch statement, you have your expression. Okay, and then the expressions goes to goes to different cases. So you have case 1. Okay, if the expression equals to, let's say, x, then you do this. Okay, if the case, if it does this, then you need to break it. What does break mean? Break means, okay, I don't want to go to the second case. I just want to stop it once it's true. So once this case is okay, then it's like, okay, forget all the other cases and just go after the brace, the closest brace. Okay, but if this case is not true, then go to this case. If this case is true, then you do this and you break it. If not, then you go to this case, then you do the sequence, and then you break it again. Okay, and that's pretty much case by case. Okay, okay. Then we have iteration structures. So iteration structures are just repeated conditions. Okay, no, repeated instructions repeated instructions that only end if a condition has been met. Okay, and you have different iteration structures. You have while, you have do while, and you have for. Okay, so first I'm going to explain about while. So what's while? While is basically while this condition is true, then do this. Okay, so let's say that if it's true, then do this. If it remains true, then do it again and again and again until the condition is false. Okay, so it's like that. So it's like a loop. Okay, then we have do while. With do while, it's like do this. Okay, while this condition is true. Okay, so it's like that. So let's say that I have this statement. So, but this statement does not meet this condition. Then is it going to do the whole process? Yeah, but only once. So it's like if it's false, it does first the sequence, then it checks the condition. So even though even though my statement is false, I'm going to process a sequence only once. But let's say that I have several. Okay, so I have several truths. So I have the first one, then it goes to a condition. If it's true, then do this sequence. So it's like you have like the opportunity to do at least one sequence. Okay, and then it goes to the while condition. Okay, but yeah, that's do while. And finally you have for. With for, it's like this. For, it acts like a while condition, but it seems different. So you have the initialization, then you have the condition, and then you have the change. Yeah, and you then have the sequence. Okay, so let's say this part. Okay, in the initialization we can have like let's say that I equals to 5. Okay, if the condition is true, for example, let's say that I is less than 4. Okay, oh no, okay, more than 4. Okay, so if the condition is true, then you change it to, let's say, we decrease the number by 1, but then do the sequence and do it again until the condition becomes false. Okay, so it's like that. Yeah, and that's 4. And then okay, we have flags. So are flags like important in this course? Of course. So when we are programming, there's only one entry and one exit, right? But we don't want to have one entry and multiple exits. We also don't want to have multiple entries or paths that are crossed paths, like you like it makes the code really messy, and it makes it difficult to understand or repair, or correct. Okay, so we're going to fill the holes with flags. Okay, and something more technical is like it must be one entry, one exit, not one entry and multiple exits. Okay, a program with jumps and crossed paths makes it more difficult to read, and that's called a spaghetti code. To avoid jumps and to avoid multiple exits, we need to create flags. So what's a flag? So let's say that I want to put these numbers. Okay, I have number 1, I have number 2, I have number 3, number 4, number 5. I need 5 numbers, only 5 numbers. Okay, and I'm gonna do a sequence with these numbers. Okay, but how does the machine know that it's going to stop at 5? We're going to create a flag, and a flag, it makes like okay, I am this number, and once it reaches this number, then it's going to stop. Okay, so it's like for example, let's say that okay, put this, you need to create a value. So if the value, if I say okay, so if the user puts as zero as a value, then the program stops. Okay, the iteration stops. Okay, and that's a flag, because there's not if we want to stop a function, then we need to have like an abortion button. Okay, like a red button, like to terminate. Okay, so that's basically a flag. You know what I mean? So yeah, so that's basically it. Like you have like you want to create 5 numbers, but you don't want the 6th number. So what I'm going to do, I'm going to intentionally put the value 0, and then the program stops and it goes to the next instruction, you know. So that's basically a flag. Okay, I'm just kind of lazy to make an example, so just bear in mind just with that. Okay, and then we have nested. You can have nested selections, and you can have nested iterations. So what are nested selections? A nested selection is just like a nest, right? So it's like a selection inside a selection. So it's like this: if condition is true, then do this. But if this condition is true, and then there's another condition, then if that condition is true, then do this. Okay, if not, then do this. Okay, and then if my primary condition is false, then do this. So it's like a nested selection, a selection inside another selection. Okay, and that's a nested selection. So it goes basically the same with a nested iteration. Okay, so with the nested iteration we have like this. Well, or I don't know, like okay, for blah 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 blah, then for blah 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 blah. Okay, and do this. So once it stops there, it goes again, and then it resets this part, and that's like a nested iteration, like an iteration inside an iteration. Okay, so yeah, that's basically all. And then we have style guidelines, which is kind of easy to understand. Just okay, I'm just going to read it because it's pretty straightforward. Okay, so with style guidelines, we need to have like a proper manner to code. Okay, it's easy to focus on the suspected portion of the code if our code is well written. Okay, you can easily see where to change and where to incorporate if it's well written, and if it's consistent and it's clear, then it benefits us because it's easy to understand, it's easy to read, and you can know what's happening. Okay, if it's a well written code. Okay, so that's all about style guidelines. So for example, let's say that we have identifiers. The identifier, it should not be like A, or it shouldn't be like A or B or C. it doesn't have like meaning, like real meaning. Okay, so it needs to be descriptive. The identifier, the variable, needs to be descriptive. It needs to mean something. I don't want to read the whole code to know what the variable is. Okay, with a brief description of the variable, I can understand without reading the whole code. Okay, so it should be self-descriptive, easily know the meaning without searching through the code itself. Okay, but if it's descriptive, it doesn't mean that it needs to be a long name. It needs to be a short name, okay, but not a long name. Okay, it needs to be short enough to understand. Okay, and another thing with identifiers is that you can cut some words. Like for example, instead of saying temporary, you can say just temp, TMP. Or instead of number, we can put just NO, which is number too. Okay, and then within identifiers, we prefer nouns are better than verbs. If it's a variable, it needs to be a noun. If it's a function, it needs to be a verb. Okay. And yeah, you also need to follow mathematical conventions if necessary. So for example, if you're going to say P, you're just going to say P, okay, or pi, I don't know, okay, or and stuff like that. Okay, that's about identifiers. You need to be descriptive. It needs to be short. It's preferred to be a noun rather than a verb, and it needs to follow mathematical conventions if it's necessary. Okay, then we have the layout. Okay, with the layout we have indentation, we have spaces, we have braces, yeah, and we have line length. Is there another one or not? Okay, and finally we have comments. Okay, so with the layout we need to have an indentation. With indentation, okay, yeah, with indentation it helps define where a code block starts and ends, and clearly shows the logic structure. So like this, if you're going to start here, you need to end it here. Okay, like it needs to be in line. For example, let's say that I have another here, then it needs to end like almost in the same position. Okay, it starts, then it ends. Okay, you're not going to put it like here, man, you know. So like it breaks the beauty of the code. Okay, and that's how indentation is great. Okay, and it's better to use tabs rather than spaces when you make some indentation. Okay, then you have spaces. So with spaces, okay, yeah, so with spaces, it goes after commas, it goes after semicolons, and it goes after an operator. Okay, so for example, let's say scanf, then it goes like blah 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 blah, then we put a comma, and after a comma we put a space, and then we put the address, and let's say choice. Okay, then we put a semicolon, enter, and let's say they want to put an operator. Okay, so we like printf, okay, let's say that I want to put %d, okay, okay, and there we go like this 5 plus 4 3. Okay, and yeah, okay, look, there's a space between the operator. Okay, so that's important. Okay, yeah, I said, and that's the same unary operators. With unary operators we talk about 5 plus plus or stuff like that. Okay, then we go to the line length. With the line length, it's just, if the line is too long, we can make like substrings. So it's like this, printf, blah 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 blah. But instead of doing like this, I can just put it like here, and then we go like this. Where's the, okay, we put another space, we put quote, then we continue, because it's not going, it's going to be here. Okay, it's going to be here, and I'm going to create a quote, then I'm going to quote. Okay, then it goes basically like something like that. So once you execute it, it's going to be like a whole string like this long. Okay, so then I'm doing like this just to like have like a proper like yeah, you know what I mean. Okay, okay, then we have braces. I don't know what I can say with braces, so I'm going to omit it. We're going straight forward to the comments. Okay, so you have comments. So comments are great, are really important because it gives meaning of what you have done. Okay, I'm not going to read the code for itself. First, I need to read the comments so I can know like an information or an outline. Okay, like a brief information about something. Okay, it needs to be brief. Okay, and it needs for every document you need to have like a title, a source file name, an author name. Okay, and it summarizes what the code does. Okay, we need to align the comment with the described code, indented both identically. Okay, and finally we have magic numbers. So let's say that I have pi, and this pi equals to 3, 4, blah 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 blah. Okay, but it's a constant. So there are two ways to do that. We can put a constant pi which equals to blah 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 blah, and then there's another way which is just we put it upstairs and then we put define pi, but instead of the assignment operator we just put it like this, right? So yeah, that it goes below the include, the hashtag include. So yeah, there are two ways, okay, to do like constant things. Okay, because there might be important values that denote mathematical constant rates or default values. Just so you can use like you can use like a constant, an unmodifiable constant or variable, and a macro directive. Okay, so yeah, stuff like that, like is like define plus the symbol plus the value, and here it's just constant plus the symbol, okay, equals to value. Okay, constant, okay, I forgot to put the type, so like this, constant plus a data type plus a symbol plus a value, okay, with the assignment operator. And that's pretty much it. Thanks for watching. It's 2:35. Oh my god, I need to sleep. Okay, bye.